chasing, leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on
right. Hey, good afternoon, evening to everyone. Hopefully you had a good Tuesday. So tonight we're continuing our coding project called NetCheck, and I guess I'll start with kind of our to-do list. So I think I brought this up last time, but I use an app called Todoist. And I use it for tracking multiple things in my life. But for the purpose of the stream, I'm going to go through, try to before like we start into coding or anything like that, that we'll start looking at, what's on our priority list, and, some things that we're going to focus on for this stream and the streams to come. So there's a good chance that this will be migrated over to GitHub at some point, so that way these issues can be tracked, or I guess they're not really issues, it's kind of like a to-do list. So but either way, this hopefully will be migrated over to GitHub and the project repo, so that way anyone that downloads or clones this project can see kind of what we're working on. So let me pull up Todoist, and then we'll get started here. I think I actually have it. Yeah. All right. So I went through and kind of prioritized, and let me just make sure that. Yep. Yeah. Okay. Sorry. Some of the orange and the yellow. I thought they were different priorities, but I believe it's just orange and it's the same priority. So what we'll be working on, you'll see, red is priority 1, orange is your kind of priority 2, and then, your lowest priority is going to be the blue, which is priority 3. So I sorted by priority. So the things that we'll be working on tonight are related to storing the job results. And as I mentioned, NetCheck is a tool that's used to perform a series of tests against a network device, and then return those results. And they can be returned in a HTML format, so like your web UI. You should be able to, I'm also building an API that will accompany that, so that way you could even do an API call to return these results, start a job and return the results. So what we'll be working on tonight is adding those job results to our backend database. And I think I mentioned this before, but I'm using SQLite, which is essentially just a file database. It's a single file, super easy. If you ever want to get started with databases, or just kind of understanding how to store persistent data, then you'll want to use a database and start with SQLite. So that's what we'll be doing. We'll be looking at SQLite and figuring out how we could store these job results into a database, and then also how to add the job results to the API. So I guess that can be kind of confusing if you're reading this. We're not really adding the results to the API. We're essentially creating an endpoint to get those results from the database. So maybe what we'll do is call it add job results endpoint. Cool. There you go. So maybe that won't be as confusing. All right. So we know what we're working on here, and I'll come back to this, and that way we kind of have a better understanding as we go through. However, there was a couple kind of to-do items, action items from the last stream. One was figuring out how we can connect to our database, so that way we could see, as I mentioned, I have like these fake kind of dummy records that are added every time the application starts, and that's mostly used just as like just checking APIs, checking that we can use our API to get results, that we can, they're just used as dummy variables and dummy results. So that way, it's used for testing. So in the last stream, we had issues gathering our results from the database. And I figured it out, actually, I believe it was yesterday night. I, I didn't have SQLite installed on this, since I'm using WSL, or Windows Subsystem for Linux. I didn't have it installed. So there was my problem. I didn't have SQLite installed, so obviously it didn't recognize the command line commands. So I got that installed and we're able to interact with it through the command line. But on top of it, I also was able to I installed DB browser for SQLite, and I can actually bring that up now. So it's super simple. I've heard of it, and so I was like, besides going through the command line, I figured this would be a better way to look at the database. So, adding the database is already here. I made sure that was set before stream. But if you wanted to open up a new SQLite database, or I should say an existing, because you can create a new one. But let's say you created your own SQLite database, you could open it up, and literally, like I said, it's literally just a file. So in the project, you could see right here, it's kind of grayed out. So I'll kind of bring it up. And it's not supported, so you won't actually see data, but it gets generated, like I said, with whenever the project gets executed, essentially, or when the application is started. So, and you could see that in the main code up here. So on startup, create DB and tables. So, yeah. That gets created, database gets created, and all I'm doing is literally reading this file, and it ends in the .db extension. So this is essentially it, and you'll notice there's a kind of a repeating trend. Well, it's because I have 3 records, and every time I restart the application, it just kind of builds. So right now there's 50 records, but I'll start out with the schema, and this schema may change. This is kind of just what I thought of off the top of my head. This is using, storing the name, when the test was executed, the success rate, so that's a percentage, the failure rate, another percentage, the number of tests passed and the number of tests failed, and then this test ID. This is an auto-incrementing number, and so that's more or less just used as you could, if you wanted to, like through an API, if you wanted to get all these test results, you could use the test ID to get a specific test record. So I think that the ID is always useful, having some sort of unique identifier. Obviously, like with the database, it's required. That's considered your primary key. But I figured, let's start with the test ID, because that will always be unique. But as far as whenever you're trying to call data from the database, most of the time you want some sort of value that is familiar, or that is searchable. So yeah, you might run like 10 test cases, but you don't want to have to remember, okay, was that the 5th, the 6th, 7th test case that I ran that I want the results. So that's where I'm trying to figure out whether we should use the name, and then how we could update the name based on the test, and something that's memorable with that. So that way the user, can figure out, okay, this is the test results that I'm looking for. Like I said, right now the test ID works, and maybe that's what we do, or what we use, but I'd really like to figure out something related to the name, or some other kind of memorable item. So this is, like I said, this is the database. Pretty simple at this point, and I guess I probably could have called this column test name instead of just name, but yeah, this is the database, and we could use this as reference, and I'll definitely be using it later in this stream, and most likely in future streams. That way we have a reference point of as we manipulate our database, or let's say we need to store items in our database, we have an idea of how it's structured. And I guess one last quick note, I keep referring it to as a database, but technically the whole, a database has tables, and then within tables are your rows and columns. So technically this is called the test results table within the database. And the database name, I believe, is literally just called database. So that's where, so really it's the database, which is named database, and then the test results table, and then the rows and columns within the test results table. And these are obviously your rows, and then your column names are at the top here. So just wanted to clarify that. All right. So, so the SQLite, and then there was one other item. Connecting to my virtual lab. So I'll get into that here in a second, because that's kind of a whole other explanation. The only other thing I wanted to mention, and this is probably something I could pull up. Let's see. Just pull over to the side here. If anyone's been watching, or cloned this repository, you'll notice that. No, that's the latest. Okay, yeah, it is in the latest, one of the later commits. So you'll see that I added a code formatter, or it says code style, but it's a code formatter. And what a code formatter does, and you can see that 17 files were changed, 318 additions, 204 deletions. But essentially what a code formatter does, and I'm using, the one I'm using is called Black, but there's other ones out there, and what it does is it formats, crazy enough, formats your code. And the point of that is, everything from the line length, so the number of characters you can have on one line, to indentation, to, it basically keeps your code uniform, and there's many perks to that. The biggest one is really just having one uniform styling of code. So if you go to the application real quick, and let's just go to a front end template, right? Nope, that is not a good one. Results. Wow. Actually, I take that back, because it is a Python code formatter, so probably should use a Python file. Right, so here's a good example. Kind of scrolling down pretty far for this. But essentially, this one's kind of tough to. Oh no, this is a real good example, right? So part of, and you could read, like if I pull up Python Black code formatter, you can read the documentation that Black offers, and it'll tell you. Hold on, let me pull it up here. Read the docs. There we go. That's what I was trying to pull up, and it'll show you kind of the rules and kind of the what it goes by. So I really wish it would I could show you a pretty good example. Guides. There we go. The black code style, maybe. There we go. Here we go. Okay, so this is the black code formatter, and if you look, it tells you how Black wraps lines. So and PEP 8 is actually, that's more your official from Python. So Python has kind of these guidelines that are written, and they're called PEP. Don't know, I forget what that stands for, but let me pull it up real quick. PEP 8. The style guide for Python code. I know what PEP 8 was. I don't know. But basically think as anytime you see PEP, and there's hundreds of them, Python 3.10 was just released yesterday. And, they added, I forget how many PEPs, but essentially what they are guidelines, and they explain, what they're used for. I mean, and they're really long. So I know this one. And it'll tell you, like, PEP 8's pretty good with its documentation because it'll tell you, I mean, even the slightest little, like, instead of having, you don't want to have a space between, an argument from a function call, right? Most people would just do this by default, like, obviously you wouldn't have a space, but, like, PEP 8 would enforce that. So it would make sure that, if you run the code formatter and you had any sort of function calls that had that space between your argument list and the actual function name, it would fix that for you automatically. So, and then just some of these are just like, okay, like why would you ever put that, I'm not even going to count, but all those spaces between, your variable and then the value, right? You would just put a space equals and another space and then your value. So, but I guess going back, so black actually follows PEP 8 to a certain degree, and then there's some things that it does change, and you'll see here it does, the coding style used by black can be viewed as a strict subset of PEP 8. So it's not that it's different, too different. So if you want to use PEP 8, you can. Black, I've had experience using it in the past, which is why I'm using it for this project as well. And you could read through. I mean, I've personally never read through all the documentation. I'll read specific, like if let's say, I'm using this, like, use an IDE like VS Code, you can actually configure it to whenever you save the file, it will do the formatting for you. So it will format to a specific formatter. And there's some cases where I've saved it and I'm like, okay, I wish that those characters didn't end up on a new line. And so I would look at line length, for example, and you would see that it defaults to 88 characters per line. So, and it happens to be a 10% over 80. So, and PEP 8 is used in the standard library, and I know that because I've looked at this. 79 is what they consider to be, the standard line length. So, I mean, it is, honestly, it's just your preference, and all of this is customizable. So, you can use different ways to, customize any of these formatting tools or linters, for that case. So we'll get into that though, kind of in future streams. That's something you probably should set up at the beginning of your project, but because our project's so small, I figure that's something that we can kind of learn and go through together, so that way, we can all kind of, there can be any, questions in the chat, we can kind of go through it, because a lot of this stuff is just like, especially if you're coming from network engineering, you're just trying to figure out how to build a function or a class in Python. All this, linting, formatting, all these tools that help you automate, just some of the most basic things are really forgotten about until you dive into the network automation DevNet track. So that's why I'm going over this in such detail is, you might, 5 minutes ago, you might have been like, oh, okay, got it. Like it formats your code, but unless you dive into the documentation or really understand like why it's there, it's most of the time forgotten about. So anyways, that was a super long tangent to just say I added the black code formatter to this repository, and I manually ran it against the repository, which is why you see all those different adds and deletions. from the latest commit. And then in the future, I plan to add it as a pre-commit hook. And basically what that does is anytime, in Git, whenever you want to save your changes and commit them, you can actually create these hooks where it runs a list of tasks. Most of the time it's used for like linting and formatting of code, but that's we'll build that as we go through. So like I said, it's definitely probably something we should have done at the very beginning, but I wanted to keep a lot of these things open. A lot of the stuff that's assumed a lot, and then if you watch any sort of other software development, it's not really like I said, it's just assumed. Whenever you look at watch software developers kind of doing a lot of times they have linters, formatters, unit testing, integration testing, and we'll get into that as well. All of that's already kind of set up. The unit testing, integration testing, that's more test-driven development, and I know that's a shaky topic, so I don't want to get into that too much. But there are developers that if you want to follow test-driven development, you start with your unit tests and build those, and then build out your actual your modules. So, but we'll get into all that. But for now, let's take a look at our to-do list. Like I said, I'm glad. I'm gonna keep this up all stream so that way I don't go on tangents like that. For 10 minutes on code formatting. And if there's any questions, I see a few people on YouTube and Twitch. Any questions, feel free to put it in the chat. I'll definitely answer them. So, all right, let's get back to what we're actually gonna be working on. So, I know it's listed second, but we have to order of operation. We have to add the validation job results to the database first. So, I think as I mentioned, we get the results from the tests, and I'm trying to scroll down to it as I'm talking. So we get the results from the test, and then we pull out the values that we're looking for. And so the way that's done is, like I mentioned before, I have kind of a list of what I'm calling helper functions. Probably not technically the right term, but they do a specific job and they do it well. That's the best way to describe a helper function, kind of in my mind. So pulling it up now. So we went over this file before, so I'm not going to go into it in depth, but you generate the testbed, and I probably need to just add it to, or change that function name to generate single device testbed, because it only takes in one device host name and IP and operating system. So it builds a Python dictionary, which we've looked at in the past. You could build a Python dictionary, or just a simple YAML testbed file, and PyTS documentation kind of highlights all of that. We're storing it in a temporary directory, and then we're running a PyTS job. So this is a little more in depth. I actually use the sub process module, and what that does is basically you can highlight over it and see everything, but what that's doing is essentially running this command from a shell. So it would be equivalent of me, coming down here onto the Linux host shell and running, PyTS run job So it's equivalent of doing that, and so that's kind of the way I'm getting past. I want to get the job results, but I want to use the EasyPy execution method that PyTS provides. So that's why I'm using this sub process. So, and all the arguments are just literally what I would type in a terminal. So you'll see PyTS run job, the file name. So obviously that's something that's going to change depending on the type of job. For right now, we just have the circuit upgrade test. So that's the only one that's running. But that can change, which is, you see here, that's passed in as an argument, the job file name. And then there's a couple little options that are added, basically points the archive, where to archive the file or where to archive the results, and then the name of the archive. And I'll show all that as well. So, all right, so we run the PyTest job, and then we have to get the job results. The way we're getting that is the results path. So we're basically, it kind of runs in like a sequential fashion. We run the job results and we return the results path. We then use that results path in our next helper and say, okay, well, let's get the PyTest results. So tell me where that lives. And you'll see here, it's basically, it basically is like using like a relative path. So, if you know the difference between absolute and relative paths, absolute is where you are at in the file system, and from in Linux it'd be your root directory, but in Windows it might be your C directory, or your C drive. So starting from the very base of the file system and kind of moving up. Relative would be basically where you're at, and then where relative to where you're currently at. So for example, if I needed to let's say I was in the main NetCheck file or project folder, which I'm actually in right here. Now I'm in. So relative would basically say, okay, helpers, if I wanted to get to helpers, all I would do is cd helpers, right? However, helpers if I wanted the absolute path of helpers, this is the absolute path. Starting with the root, and then going through home, my home directory, code, NetCheck, the actual NetCheck, project folder, and then helpers. So just a quick side note about relative and absolute path directories, or paths, sorry. So anyways, the path is passed in so that way this function knows where the results are. And what it does is it will actually go in, find the archived results, and the archived results are always going to be a zip file. And it looks for the results.json file and puts it in a temp results folder. It also looks for the device logs. So I'm going to actually show this to you here in a few minutes. But every time you run a job, there's a bunch of files that get produced and zipped up into an archive file. So what I'm doing is basically taking that archive file, extracting everything from it, or I'm sorry, not everything, extracting only the results.json file, which you'll see has a lot of details about the test results. And then also pulling the device logs from the raw device logs. So whenever I say device logs, I'm actually talking about like the raw show output. So something you'd find like in the CLI. I'm pulling that file as well because that output's recorded and stored in a text file. So I'm pulling the results.json, which I'm going to parse, and the device logs, or the raw CLI output. And they're both being stored in this temp results folder. So, and you'll see here, I open the results.json file and convert it to a Python dictionary. And we'll see why I'm doing that here in a second. So that JSON file gets converted to a Python dictionary, and then a dictionary is returned and then fed directly into my next function, which is parsing the results. So just as a recap, we've ran the PyTest job, we're getting the results, and now we're parsing out the values that we want. So the job results dictionary is a dictionary, and it's going to be returned. And this is kind of where your type annotation comes in. I think I talked about in the last stream. I mean, it's so valuable because you know exactly what kind of files getting passed in. I'm sorry, what the type is, the object type, and then what's being returned. So you know you want a dictionary to be passed into this function, and then a dictionary is being returned. So I'm basically passing in all the results. So that results.json file, and like I said, we'll take a look here in a minute. And I'm parsing out only the values that I want. So, and you'll see I'm actually using the DQ module, which is a super awesome module found in the Genie library. And basically what DQ stands for is dictionary query. So, if you've ever seen a nested Python dictionary, so a dictionary within a dictionary, and ever tried sorting through that, let's say your value is like 3 dictionaries deep, you just have to, normally you just keep doing for loops and you just keep going and going and basically looking for that one value. Well, here the DQ module, and I'll bring up the documentation here in a second, will actually provide you with different methods that you can use to extract the values you're looking for without going through all those for loops. So in this case, what the screen is blurry. Well, let me see. Sorry about that. Harshith. Okay. So Harshith says that the screen is blurred. I'm not seeing any sort of drop frames on my side, and I'm zoomed in. Let me see if I zoom in again, if that can help. Editor layout. Zoom in. All right. Harshith, let me know if that helps. Yeah, because I can see on my stream preview that it's pretty big now. The text is pretty big. And I know there's a difference between the text size and it being the quality of the stream as well. I am capped at 720p and 30 frames, but I'm not gaming, so the frame shouldn't be an issue. But yeah, let me know if the screen, if it's still blurry for you, or if the zoom helped or didn't help. All right, so where was I? All right, so yeah, so what I'm basically using, I'm using that DQ module I explained from the Genie library. Text is still a little blurry. Okay, well, what I'll do, I'll just stay zoomed in. If you could, I don't know if you can do this on YouTube, check your stream quality and try to make sure that it's at 720p. It should be outputting that. So if that's still, I'm not sure about your internet connection either, if that's an issue as well, but I'll just keep it zoomed in. This is the best kind I can do at this point. So hopefully I'll talk through as much as I can so that way you don't miss anything. But I appreciate you letting me know about the stream. Okay. So yeah, DQ module. So we're using a couple methods. We're using the contains key value, and we're using the get values. These are 2 different methods offered by DQ, and I'll just pull it up real quick. PyTS docs, or no, Genie helpful functions. I think it's called helpful functions. Now it's better after I change it. Oh, okay, cool. So since you changed the quality, I'm gonna zoom out. Let me know if that's still okay. The only reason I like to zoom out is because it's tough for me to, it's a lot of scrolling. So yeah, let me know if I need to zoom back in, but I just zoomed out for right now. Have my own had my own blog pop up in my Google results. That's funny. All right. All right, so this is what I was looking for. Useful libraries. Okay, cool. Harshith, it's good after zooming out. All right, cool. I appreciate that. Thanks for letting me know. Okay, and that kind of, for anyone else watching, make sure that you have the stream at 720p. That should be probably the max setting. I know because we're looking at a bunch of text. I just want to make sure it's the clearest it can be for everyone. All right. So dictionary query. So you can actually, I've actually used this library outside of PyTS and Genie and like outside of this project, just to query dictionaries. So like you just have to install the Genie library, and you could use this with literally anything. So that just as a heads up, definitely feel free to, you should use it outside of PyTS, and you could use it really anywhere. I would say even outside network automation if you have other, a side project or something like that. But anyways, so the two methods that we're using is contains key value. We'll get back to get values in a second. Contains key value and get values. So and I'm gonna just zoom in real quick so that way everyone can kind of see. So contains key value here. What it does is it slims down your dictionary to just the values you're looking for. So, for example, let me just go up to the contains real quick. So yeah, contains actually has a little better of a definition. So it filters down the dictionary and only keeps the paths which contain the provided value. So let's say that you have a network device that has multiple line cards, right? And in this case, you only want any, and within, let's say there's a dictionary called line cards, and then nested within that there's a dictionary called 1, and then 2, 3, 4 for every line card module there is in the network device or the chassis. Well, using contains, you can actually say, I only want the line card 4, line card number 4. All the other nested dictionaries can be removed, and you essentially get a new object from that. So it kind of, think of it as it trims down, trims the fat from all, to whatever you're looking for. It makes the dictionary lean. So once it's lean, you could then use for loops like you traditionally would, or you could use another method provided by DQ. And in our case, we're actually using the get values as well. So going back to contains key value, it basically, the way you look at it is, instead of having, just contains, so let's say, we know out of a list of routes, we only want, a certain /16 for whatever reason. We can use contains for that, right? But let's say in our case, contains key value, we're looking at a specific, we want a very specific value. So, in our case, what we're using it for is we're looking at the summary of the report. So I imagine, I forget all the key names, but we'll look at, like I said, we'll look at it here in a few minutes. But within the report, there's a summary, and then there's, I believe, test cases or test suite. And then within that, there's also like your individual tests and your individual steps. So it can be broken out. It's a pretty nested report. So what I did was I said, okay, I'm only looking for at the summary level. So I'm only looking for out of all the tests that I'm doing, I only want pass or fail for the entire job, right? Because at this point we are looking at the job results. So we're looking at the summary of all the tests. And we're going to store it in this test suite results variable name, right? So, I used the DQ module, got it slimmed down, cut the fat off, and now we're down to just the summary the summary section of the report. And then within that summary section, we wanted certain values. So I don't, I could, when we get to it, we'll go through it, but we could go through and say, okay, now we have the summary, let's do a for loop. And let's say, okay, let's call it for value in summary. If value equals success rate, then store that value. Or, for if the value equals total, we'll store that value. Now, instead of doing that, what we did was I said, okay, well, within the test suite, which I actually had it highlighted for a reason, I have it highlighted just to show you that we're taking that test suite, that slimmed down dictionary, right? And we're getting specific values from that. So in our case, we're looking for success rate, total, passed, and failed. So get values is a little more straightforward. And let me bring the documentation back up. So you'll see that this is something where it collects all the values of a specific key. So this can get a little tricky if you have multiple keys with the same name, because then it's a little confusing to the DQ module. But in this case, we only have one value called success rate, passed, failed, total, right? And I guess I should say that kind of complements why we slimmed it down, right? Because if you can imagine, I mean, how many passed and failed tests are there, and how many times is the passed key used within that JSON, that those nested dictionaries, right? That report a bunch. So in order to avoid getting all the past results and putting it in a list and then trying to figure out, okay, is this past result for the summary or is it part of the individual tests? Like, where are we? We actually are saying, no, we just want the summary section of the report, and then we want the success rate, total, passed, and failed. So back to the documentation real quick. We'll return a list of the values that we find, right? So as I mentioned, we collect all the values of a specific key, right? And so in this case, the example, it says, all right, we're going to parse show interface and then get the values within of show interface. So in this case, we're getting just the interface names. And so I don't know what that parsed output looks like, but I can tell you that, within the index 0 of the list, you're going to have all your interface names. So in our case, we get the values of these keys, and we then update this parsed results dictionary, which we initialized up here, and return it. So at the end of all of this, we parse out all the we run the test, we get the test results from the temporary folder, and then we parse out the results into a nice dictionary. So we essentially break down the larger results dictionary and create our own dictionary of results. And that, honestly, this is what we need to do. This is what we need to use in creating our database model, which then we will store these results in the database. So that's kind of, in a nutshell, all the different helpers and how we're using, why there's so many different ones. So I think I mentioned this on one of the first streams is, I have all of, at the top here, I have all right here. Yeah. So I've imported all these individual functions, functions. And, I explicitly put them in here so that way you could see as you're looking through the code, like, okay, this is where this, this is why, each individual function is written out. Because we could just, honestly, you probably could do just one function to where it gets the results, parses it, reads the results, and returns them. But at that point, if there's way too many things that can change, and you try to keep functions into a single action, right? So, so this is kind of the results. This is kind of those helpers in action right here. So this is whenever we submit a test, it goes through and and does everything we're looking to do, right? So generates a test bed, runs the job, gets the results, parses the results, and then reads the device logs. I didn't go over that, but essentially all it does is, let me scroll down the bottom here. It finds the temp results folder, and it finds the file name. It actually does a tiny little check, because we know in the temp results folder there should only be two files, results.json and then the device logs itself. So it will actually check to make sure there is a device log file within that temp results folder, and then it will open it, and then read the results, read the text file into a string, and return the results, which you'll see in action here in a second. All right, so I think we've read through enough code. Let's get to actually using this tool. So I have it running already, and I think if you followed me on Twitter, I mentioned, well, last time I mentioned that I couldn't get my VPN working. And this might actually be a good idea for a video, a separate video, like a recorded video. I use EvenG as my virtual network simulator. Basically, you build virtual labs within EvenG. Other popular ones would be like GNS3 or Cisco CML, so Cisco Modeling Labs. So I use EvenG. I've used it I started with GNS3. I had a hard time with the whole server client concept. I just had random issues, something like the server and the client didn't have matching versions. So I switched over to EvenG probably about 2 years ago. Started with the free version, and then they had a sale last year. I believe it was around Black Friday. It was around the holidays. And so I bought the paid version, and there's just some slight perks to it. I can't think of all of them right now, but essentially I'm running EvenG in a Google Cloud instance. So I created a VM, and I installed EvenG on the VM, and the way I'm able to communicate with it is I can communicate over, it has a public IP address, and this always changes, so I'm not too worried about anyone, hitting it at this moment. And if you're watching on YouTube, it's definitely not active, because I shut down this lab after, every use. I don't keep it online, and it doesn't have a permanent IP address. It just grabs a random IP from Google Cloud. But essentially, I log into it, and I could do everything I want from here, because EvenG offers an HTML5 console or a native console. And native console uses your terminal, so it could be secure CRT, it could be iTerm, it could be whatever, or in Windows case, Windows terminal. But because I was using the public IP and logging into it externally, I was using the HTML5 console. So you'll see here that this actually is a console window within EvenG, and you'll see this is just a very basic setup. I literally just got SSH working on it, so nothing crazy on it yet, but I got the base configuration down to where we can add to it. You may notice some of these other boxes here about BGP. I don't have that set. I did have it set up, but I did some changes to the VM in Google Cloud, and for whatever reason, all the routers lost their configs. So this all needs rebuilt. But let's talk about how I connect to it. So with EvenG, there's multiple clouds, and that's what they're kind of referred to. But you can add a network, and then within, when you add a network, basically here's the different clouds. And these clouds actually match up to virtual NICs. So, if you're thinking of from a VM perspective, this has 9 different virtual NICs. And if you've used any VMware products, you're very familiar with like the individual, like the private networks that you can, I forget the name of what they're actually called, but you can actually put them, like create like a bridge network. Like you can actually have multiple VMs on the same host talk to one another through like this private network. Kind of the same concept. You could basically have these are little virtual, think of it as like virtual switches in that way. However, what I did is I basically enabled IP routing on the VM, and then made one of the VNICs, in this case PNet, it's called PNet 9, but think of it as like Cloud 9, funny enough, as the gateway, right? So I made a note to myself, and this was before I figured out how to make that IP address persistent on the VM, like after a shutdown. But so I would literally add the IP address to PNet 9, which in turn is Cloud 9. So if you were to, come back to add the network, all I did was change the type to Cloud 9, and just change the icon, number of networks to add, and then just called it whatever it's called here, GCP network. So the idea was that any VM within my Google Cloud instance, or VPC, assuming that's what it's called in the Google Cloud GCP world as well, the Google Cloud. But yeah, any instant VM within my Google Cloud in this specific region, which I'm using this same region across the board, can talk to these individual routers. So I basically created a gateway, enabled IP routing on the EVNG VM, and then I had to, within Google Cloud, added a route to say, all right, any traffic destined to 192.168.250.0/24, use the EVNG as its next hop. Okay, so that way, it's a little different than, in a network engineer sense. You're like, wait, you used a VM as your next hop. It's like, yeah, instead of using an IP address as your next hop, if you created like a static IP, or I'm sorry, static route, you would put like, okay, this subnet would then, the next route goes to this IP address. Well, in the cloud world, you would say, no, it goes to this instance, right? So basically any traffic going to this /24 subnet will be routed to EVNG. So back to my router, you'll see, okay, this gig 00, which is connected to my Cloud 9, or this management network I basically created, is I configured the IP on this router, and then also on this router, and you'll see, I'll just log in just to prove it to you. So 192.168.250.3. So within GCP, the subnet should be available. We should be able to ping, and I use this subnet specifically because I knew it's out of all the different subnets that were found in GCP, I didn't really see much about the 192.168, kind of that Class C range. So I just used it. I won't need more than 254 addresses, 255 addresses. So it works for me. So yeah, so that's it from an EVNG Google Cloud setup perspective. I do have a couple blog posts. So if you go to devnetdan.com, you'll find a bunch of blog posts related to setting up a CI/CD pipeline, and part of that series is setting up this Google Cloud environment. So, and I make a reference to another great blogger, and you can follow and check out his blog as well, because he had a little more in depth of how to actually set this up. Mine was more or less following some of his steps and basically providing my input on, this is what I found to work, this is what I didn't find to work, any sort of warnings, anything that I was like, make sure to set this up. So for example, on the VM, you have to make sure that IP forwarding is set up before you deploy the image or start the VM and build the VM. So during the building process, you want to make sure that VM has IP forwarding set up. So, but it's all in the blog post. All right, so we have EvenG set up. We have GCP. It has connectivity to the other VM instances within GCP. So you're probably wondering, okay, well, how are you from your desktop getting to these routers, to your EvenG topology? So I just recently set this up, but I have a OpenVPN instance set up. So GCP has a bunch of images that you can just install, and an OpenVPN access server is one of them. So I spun up a new server, an OpenVPN server, and then essentially just downloaded the client to my desktop, and I VPN'd from my desktop to the OpenVPN server, which essentially puts me right into my Google Cloud VPC. Now there's probably a bunch of, you could probably look at this a bunch of different ways from a security perspective, but just kind of, so everyone knows, all these instances are shut down immediately after testing, and ultimately it's a test environment. So there's nothing in production here. There's nothing from any sort of sensitive data being passed through here. This is literally just a testing environment. So it's testing from a network perspective, testing routing protocols, how some sort of change would affect a specific setup, to testing my network automation scripts. So just want to put that out there just in case, any comments come saying, hey, you're putting a public IP out there, you described your entire setup. Honestly, it's fine. I've removed the admin passwords, remove the admin account. So even if you were to try to log in, you shouldn't. So, all right. So I am VPN'd into, so you'll see here, I'm VPN'd in, and yes, that is one of the admin account, the default accounts, but the password's been changed. But you can see I'm VPN'd into the my Google Cloud environment. Let me just pull up a terminal. So .1, as I mentioned before, is the kind of think of it as the gateway, which is on the PNet 9 interface on the EvenG virtual machine, the VM. So you can see, okay, connectivity's there. .2, if you remember, is router 1 down here. And I know it's hard to read. I have to change that text, but essentially this is router 1, where it's in the orange box, and then router 2 is in the yellow box here. So ping.2, that looks good. And then .3, which is router 2 in the yellow box. So connectivity looks good from my desktop. So that means we can actually run our tests against these devices. And I mentioned it's a very vanilla setup, so not much to test against at this point. And as you can see here, I think at this point I don't actually have the BGP neighbors set up, or the test set up, but I do know that but without me just guessing. Let's go to circuit upgrade. And I'll just quickly go over, the actual test. So you'll see common setup. So I think I went over this, and if I did it, you could check it out in the PyTest docs. But you have a common setup and a common cleanup section, and then in between you have your test cases, or what you call your test cases. So the common setup, the only thing I'm doing is connecting to the device, and that's about it. I pass in the testbed and then pull out just the single device from the testbed. And if you remember, we generate the testbed in this helper function right here, right? And so you might be like, okay, well, how, because in the web UI you ask for the host name of the device, the IP address. How do you know what? I know it's only a single device, but how do you know which device to actually, how do you identify it? So in the testbed, you can actually create what's called an alias. And then I just kind of stole the terminology from the documentation, PyTest docs, UUT, the acronym UUT, and that stands for unit under testing. So in all my test scripts, the ones that only require a single device, I'm actually saying, okay, I only want the UUT device. And PyTest knows to look for that, the host name or the alias as kind of the identifier. So because that's statically set as the alias, that's why, we're able to confidently call on that. I guess one other side note I didn't mention. So I'm actually using environmental variables for my username and password. So you'll actually have to create those whenever if you clone this repository and want to use it. You have to just do the export and then the name of the environmental variable, and in this case it's called all capitals Eve_user and Eve_pw, and then just make it equal to whatever a valid username would be on your network device. So, and it's using port 22 SSH. Everything else is pretty standard. Anything highlighted in orange is actually what values that we got from the front end. So basically what the users plug in. So host name, device IP, and then OS type. All right, so common setup, we connect to the devices, in this case just the one device, and then we dive into the test case. So as I mentioned, this test case isn't complete yet. However, before we do anything, we do just a quick setup test. So what we'll do is say, if the device is connected, then say, yep, successfully it's connected, or no, never mind, it's not connected, right? And self.failed basically, as if you're familiar with Python classes, self refers to the instance of itself. And so self.failed would cancel out the entire test. So that's kind of like if it's not connected, then the whole test is going to fail and it won't try to go through any of the other tests. So checks to make sure the device is in a connected state. And then we check for CPU utilization, memory utilization, and we can dive into these a little more because this is very cool, but I want to run through a test case and show you the results before we dive into any code. All right, so we check memory utilization, CPU utilization. We verify the iOS version. So I just kind of picked a standard iOS, or I'm sorry, that's the iOS XE standard, right? Because iOS XE is in the 16.x, 17.x range now. And then the iOS standard. So it's kind of neat. I was able to build out these tests to say, okay, well, if the operating system is iOS XE, which is what the user selects on the front form, then we want to make sure that the parsed out OS version is equal to a certain value. And then if it's equal to, let's say it's an older device that just is running iOS, then we'll run a test to make sure it's equal to a separate version. So it's kind of neat in that way because that allows this test to be very modular and allow it to be very flexible. So think about it. I mean, you really could, if you wanted to, use this test and create a new variable called like NXOS standard for Nexus, because they have like a separate OS numbering system as well. You're not going to find 17.3.3 for a Nexus version. So you could do that and then make another kind of if statement to say if the device.os is equal to NXOS, then check it. I do plan to make one a standard for ASA, since that's one of my drop-down menu items. So that'd be like your firewalls, and that also has a separate recommended iOS. So, it's very, and that's kind of like the nice part of, as like the PyTS docs refer to, like everything is an object. It really takes that object-oriented programming, those methodologies to a whole other level, because it actually it declares and says, okay, well, anything after the dot basically is an attribute of this object, the device object, right? So dot os, where else did I see one? I thought we had looks like we're just using os, but like everything else, like using, if you want to use any of the API methods, dot API, you want to parse any sort of show commands, dot parse, like everything's kind of centralized around the single test device, which I think is pretty neat, especially for readability purposes, if you're kind of new to this. All right, so verifies the iOS version, and then two other external testing external pings. So I originally had this test for pinging like Google DNS, like 888, but instead I changed it to just pinging what I'm calling the PE, the peer IP address. So PE stands for provider equipment, for those that don't know, and that most of the time is just your local ISP device on the other end. So if you ever connect or do a circuit upgrade, obviously the first thing is to connect the new circuit, whether it's Ethernet cable, fiber cable, to your device, and then you just run a quick ping test, and basically think of it as like, your device, provider device, that's literally the only thing that really is in the way. If you can't ping the provider, then you obviously won't be able to ping anything on the internet. So unless you're using, like, if you have two routers at the site and you route through the other routers, and that kind of gets a little messy, but ideally, obviously, you want to ping the provider equipment first before you try pinging anything on the internet. So, and it worked for this example. So all I'm doing is pinging that management gateway IP that I was describing, that IP address that's on the EVE-NG VM, and we're pinging it 100 times. So, and just a side note, like this is one of the coolest things, I think. Like, instead of writing any sort of function to handle pinging, doing something as simple as a ping from a device, PyTS or Genie offers a device API, which we'll jump into probably the next stream. But essentially, it provides a bunch of different methods, right? And beyond ping, but ping's one of the most basic examples, right? But you do .ping, and then you feed in basically these keyword arguments to say, all right, well, what address do you want to ping, and then how many times do you want to ping it? Think of it as like an extended ping. If you're familiar with doing extended pings through the CLI, a lot of those options, the extensive options, are provided through this function. So, but you'll have to double check. You should be able to look up Genie APIs, or available APIs, available parsers, and look for the ping API, and you can see the additional options. But I only needed address and count. So so it pings. If it's successful, pass. And then lastly, it parses out the logs. So what it'll do is actually get the logs, and then within the logs, do show log. It will find any sort of error, like, if familiar, this is probably CCNA, the different severity levels with logs, with your different logs, your Cisco logs. So in our case, we're looking for any sort of errors, which is represented by the number 3, or more severe. I guess that's a better way of putting it, more severe, because if you say higher or lower, then you start thinking numbers. But more severe, so you're thinking, errors 3, more severe is, 0, 1, 2, so it would be 3, 2, 1, 0. Like any of those levels, severity levels, then we'll get those values, right? And we'll get like what messages were logged. But if there aren't any sort of severity level of error or more severe, then it'll pass with no error logs. Else it'll actually fail. So this step will fail, and then the engineer can review the show output to see what the error logs were. So, all right, and then lastly, like I mentioned before, that this is kind of a required field, the common cleanup, and all this is meant to do is really, like in our case, we're just disconnecting from the device. But if we were to do any sort of configuration, like test configuration, so I always like to use the example, if you wanted to, kind of bad timing, but if you wanted to test any sort of, BGP failures, no shots at any specific companies that had recent BGP failure issues. But if you wanted to test and say, okay, well, if BGP fails on this specific router, do we have connectivity? 2, do we have, where do those routes go? There's a bunch of tests you could run. The common cleanup section is where you would actually re-add those commands. So you'd re-add the configuration. So that way at the end of your test, the devices look like they were before your testing. So you're essentially, if you broke something, then you fixed it, and it's back to what it was. So that's what's most of the time included in the common cleanup section. So, all right, let's go to our NetCheck tool. All right, so I showed everyone the web UI, I believe on the first stream, but this kind of goes over, so your home will kind of just give you a brief overview of the tool, validations, your PyATS, your actual tests are going to be run live against the network, and then analysis and about sections are still kind of TBD. So in our case, we are going to do a test on R1. The device OS, it's a virtual iOS image, so it's running, I believe, 15.2 or something like that, iOS 15.2. Either way, it's an iOS image, it's not iOS XE. And the IP address is 192.168.250.2. And this is what I want to show you. So we're running against this device in the orange block. And before I run it, let me just comment out the cleanup methods. So the cleanup methods, all they do is basically delete those temporary directories that I talked about that store the results. So the point, I want to actually pull and keep those temporary directories, so that way we can review kind of what's pulled from the archives and then what data we actually have available to us. All right, so we filled out the form, click submit. Let's enter this again. Notice that little spinny thing took way longer than I'd like to admit, but I think it's very cool. Than just having it, clicking submit and then not knowing if you click submit. So, but all right, so nothing really to look at there. You'll see in the background here though, we're actually running the PyATS, the test, and then all the show commands and everything we just went through, the pings, and then the last step is disconnecting. All right, finish the test. The archive was created. And then you'll see here device logs found and stored in a temp directory, and device logs were found in red. So the point, it's being read, and I'll actually slide this over here. So the user gets back this, I think it's a pretty awesome page. There's a quick summary over here, and these are the results that I showed you that we pulled with the DQ module. We actually pulled from that results.json file. It's just a quick little summary, and I know it might be tough to read on stream, but tells you total number of tests ran. There were 3, number of passes 3, number of failures 0, with 100% success rate. So that's just a nice visual for the user to say, okay, that's great. Like, everything passed. Over here on the right, we have the detailed results. So this is where what I call the device logs. These are actually, all the commands that were ran on the device and all the show output, the accompanying show output. So you'll see, there's some terminal length 0, terminal width 0. This is all ran by default from PyTS. Whenever you want to run any show commands, it does this, so that way the word wrapping, word wrap, and it's just a cleaner output. But there are options to where you can disable these commands for running. I know, if you're in an environment with TACACS and you don't have the authorization to run commands, go to conft and run any sort of, well, I guess these really aren't conft. If you just don't have the authorization to run these commands, there's ways around that. So you'll see run show version. It collects the show version of the device. Oh yeah, it does run some configuration commands. So you'll see, no logging console. And that's just to avoid messing with the output that's collected. Grab all the CPU information, what it's running. Memory utilization, executing show processes memory. And don't know why it has the show version there again. Okay, so ignore that section. It executes the ping command. So, I showed you that API. Well, that API then transforms what, your intent is to what, like basically a CLI command. So ping, repeat 100, you'll see everything passed, round trip time and everything like that. Show logs. So it'll do show logging, and then, it gathers all that information, all these logs, and then it runs those rules that we talked about. It looks for, for people unfamiliar, this is the severity level. So it's hard to read because of the word wrap, but there's a percentage sign, small description, and then a severity level. So you'll see severity level 5 throughout. Your line protocol is going up, down, or severity level 5. There is a severity level 3 here. So technically, actually, I may have said more severe. I don't know if I said less than or equals. Either way, we can change that. I'm not too worried about the rules itself. That's kind of the point. Once we get to once we have all the functionality added, then we'll kind of go through and start debugging and finding these bugs. But the nice thing is we have a download button, and you can save this text file. So I thought that's pretty neat that you can actually take these results and save them to a text file, and you could use it as a reference point. So that way, like, if you see like, okay, why did all my tests fail, you could see right here in the device logs, you might see like, for a common thing would be username password not accepted, or not authorized, and it would show you in the device logs. So yeah, that's it from a high level, from what the user can see. So at this point, the user knows, okay, all my tests passed, and then as proof, I have all the show commands and the output for that. All right. So let's switch over to, all right, so what exactly, I keep talking about all these temp folders, right? You know, a temporary test bed's created and used with the job, and then like just the results.json files pulled, and the device logs are pulled. So like what exactly does that mean, right? So normally we would have these temp folders cleaned up. That's, you know, down here, these commented out lines. Normally we'll go through and find these folders and then delete them and recursively delete them. So all the items within the folders obviously are also deleted. But you'll see something neat here is I've kind of went back and forth with this for a while, figuring out, okay, what's the best thing I can do with converting, you know, do I convert that Python dictionary that I showed you all, you know, 20 minutes ago? Or, you know, how do I get that into my job file, right? And because I'm running that sub process key, I'm sorry, the sub process, since I'm basically running it as a command line, like via the command line, I figured, you know, the command line is expecting the testbed to be a in a YAML format. So without, like, it's, you know, that's one of the things whenever you're developing is you read and you see other people's products or what other people are doing and you're like, oh man, that's cool, but like, does it fit my use case? And then you kind of get like that analysis paralysis where you're just just staring at your code like, man, this could be better, man, this could, you know, I should do this, I should do that. At this point, this works for me and it doesn't really take too many cycles, right? So this may be optimized in the future, but for right now, basically this YAML, this testbed.yaml file is created, and then passed into the job file, and the job file is what is ran by what I just showed you, this sub process. So yeah, so that's that, and this is kind of the result of that generate testbed file. So that's kind of where that came from. Harshit is asking, shall we run from command line? You can. So this actually, what I have highlighted here, if you run, obviously you wouldn't run it in like a list, but let's say pyats run job, and then the job file name, or I'm sorry, yeah, the job file name is actually the name of the job file. So you'll see I actually have a separate folder for job files. So in this case, I would just say job file. I would say job. All right, my auto-completion is not working. Oh, it's because I'm in the helpers. So I could do this, job run, and then job files, and then the name of the job file, right? So circuit job file. And if you're like, okay, where did the job files come from? He was talking about test scripts, like what's going on. Look at through the pyats documentation. There is two different ways of executing test. One is through what's called the standalone execution, which is meant for kind of testing purposes, and then there's the EasyPy execution, and the EasyPy execution requires a job file. The point of the job file is that you can include multiple test scripts within one job file. So let's say you're testing against a bunch of devices, and you have a bunch of different tests, but you don't want to include everything in one test script. You can actually put multiple test scripts within a job file. So, and I actually didn't show this before, but the job file is pretty simple. You basically load a test bed, and I'm using the run API from the EasyPy collection, or from the EasyPy module. And what it's doing is basically saying, okay, well, run this test script. Runtime equals runtime. That's something that if you want to know more about, I would read the documentation, because there's many things that you can modify during runtime. So the runtime is when the test script is actually ran. There's different variables and different settings that you can change. So yeah, if you want to learn more about that, definitely read the documentation. And then lastly, the testbed. So in this case, I went to the temp testbed folder, found the YAML file that we're actually looking at now, and then loaded it in as a testbed object, and then basically fed it into the test script. Hence why in here you can see a testbed parameter that correlates directly with this argument right here. So yeah, I guess to answer your question, you can run this via the command line. You would literally just take these arguments here that I have, and then just type them out, right? And so I'm not going to keep going, but you can see this job file / circuit job file is basically what this variable would be. So, all right. Okay, so wow, time's flying. Let's do this. I know I said we were going to get to the database and creating to actually do the Todoist, but I knew I was going to take some time to go over the actual network topology, so that way if there's any questions on that, I could have went further into it. So that we'll probably have to hold until the next stream for creating database, creating basically a new table model and data model for the test results. But let's quickly look at where we get the test results from, that results.json file, and the specific values we pull, and then we'll wrap up. So all right, so I showed you the test bed. That's pretty simple. Now the temp results page. All right, so before I do that, go through the temp results, just quickly, let me show you. There is a PyATS logs folder that I don't delete, but I also don't keep track of using Git. You see all these different tests that I've ran, right? Over the past few days. So these are obviously archived folders. You can actually run diffs and comparisons against the archive folders, which is pretty neat. That's like it's a completely different subject, and that's something that probably like we'll get into with as an additional feature. But the idea is, it's good to have these archives because then you can do a further manipulation or comparisons. So we store all the archives in this PyATS_logs folder, and then within this, we get the PyATS results, and we extract the results.json file, right? So let's quickly open that and make it a little more readable. Oh, that was neat. I didn't even have to right click. Just make sure. Oh yeah. Okay. So as you can see, it has a bunch of data, right? It has everything from our sections, the start time, the stop time, run time, the logs of each section, pass or fail, where the logs begin and end within the actual log file, result, whether it passed or failed, the steps within the section. So in this case, we had the common setup, right? We have the common setup test section, and then we want to, within that, we had a step to connect to the device. So here you see we connect to R1. It took 3 seconds, according to this value, right? And the result of it was it passed. So, I mean, you can see it's just, and all of these curly braces, and all these braces, square, the curly braces. These are all nested values, and you can see like I have the rainbow indentation on, all with the different colors, how deep and nested these values are. So as you can imagine, it would be a pain to drill through these. And like I mentioned before, you have to use a for loop. Traditionally, use a for loop to kind of find these values and like parse out what you're looking for. But using the DQ library, I was able to get exactly what I wanted. So first I went to report summary, right? I found the summary section of the report, and just so you can see, right? So I'm under report, right? And so this is the key value, and you'll see with the purple, I don't know how well you can see it on stream, but there's like a purple line going down through here, right? And it pretty much is the entire file, right? I mean, I'm still scrolling and it's still highlighted. And if you can see it over here, there's a little line that shows you the end. That shows you the closing brace. So that's the closing brace. So we scroll all the way to the top. That's the key. And then everything within at the high level are your values. So in our case, we're looking at for summary. Well, lucky for us, if we look up summary, we find that report summary is right here. The other values you'll find like plugin summary. This key right here, this is actually a value to task, right? And actually it's buried within a list. So it's tasks and then the index of the list and then summary. So that's not technically what we're looking for. We're looking for a key value of report and summary. And I'm not going to go through all the yellows were matching the word summary. You just have to trust me that this is the only key value of report summary. So what does that do, right? So think of it as it goes through and it basically says, all right, you only want this information. So it takes out, I mean, if you think about it, everything but the highlighted region. I mean, you're talking 95% of this this file. I mean, it strips out all of that because that's all we want. We just want report and the summary dictionary. So it filters all that, and then within that we look for the keys success rate, total, passed, and failed. If you look here, you look for success rate, total, failed, pass. I know I said that backwards, but you basically find those keys and you get the value, right? So pass is 3, failed 0, total is 3, and then success rate is 100. Let me see if I still have it up. Yeah, I still have the web page up here. You'll see, success rate's 100, total 3, pass 3, failed 0. Right. All right. So that's that's it as far as the values that we currently want. And that's for just the test results table. If we go back to the database where we want to store this data, we want it into these different columns: success rate, failure rate, test passed, test failed, and then, the test ID's auto incrementing, so we'll ignore that. But these are the different values that we want, that we need to build models for, right? So there's your data models that basically help serialize and normalize your data. So it's basically like, if you want data to be formatted, like a dictionary, for example, to be formatted in a specific way, you're going to build that data model, right? And then on the flip side, there's also table models, which basically model tables, but in Python. So it's kind of neat because you can say, all right, I want a class called test results, and within that class I'm going to have a name, execution time, success rate, failure rate, tests. And just to show you what that looks like, let's go into models. That's exactly what it looks like. We have our test results base, and we'll just focus on this because I don't want to go into each of these different results. Models, but you'll see that test failed, test pass, failure rate, success rate, executed at, and a name. And the test results, the actual test results table model, we're using a very cool library, which we'll get into next stream, called Sql Model. And it pairs well, and it was created by the same team person that created Fast API. He basically combined data models and table models into one. So you don't have to have a separate file just for models, or I'm sorry, just for data models and one for table models. You can have one for both. So and this is a perfect example. This is a data model and a table model. And you can see that by the table equals true here. And if you're like, wait, that only has test ID, well, it also inherits from test results base. So think of it, you have name, executed at, so it inherits all this and then adds a test ID, which in turn creates the test results table with name, executed at, so, all these columns and then test ID. So putting them side by side real quick, it's tough to read and it's kind of cut off, but you get the idea. Name, executed at, success rate. So that's a lot that's a lot to take in, because you're modeling your data, but you're also modeling your tables within your database. And on top of that, SQL model, the SQL model library will allow you to interact with that database. You can update it, you can add more data, delete data, read data. So there's just a lot to dive into with that. And so what we'll do is let's hold off on the SQL model until the next stream. But I will post in the chat the a link to the documentation. I think I mentioned this before. The Fast API documentation was one of the best documentation, docs I've read. SQL Model is right there with it, mostly because it was written by the same person, same creator, but he goes into all the different, why we need data models, what's an ORM, and we'll get into that in the next stream, but highly recommend take a look at this, if you'd like to. It's very awesome, very awesome. So all right, well, let's wrap up. Let's figure out what's next. So we did not get to our priority one task. In the meantime, between streams, I'll probably look over some of this, so that way I can get a little bit of a head start with the next stream. But ultimately, we still have to work on adding those results to the database, and then creating an endpoint for the API, which essentially reads the results from the database. But as I just went over, SQL Model makes that very easy, and we'll dive into that more during the next stream. So thanks to everyone that stuck around. And as always, if you have questions related to this project, network automation, coding, or Python, I definitely am not an expert in any of the fields I mentioned above. I'm just like everyone else, just learning day by day. Definitely have seen myself grow by building a tool like this and figuring things out. But if you have questions, feel free. Best way to reach me is probably via Twitter at DevNetDan. But besides that, thanks for everyone watching tonight. I'll send out a tweet, but I will not be able to stream this Thursday. I have some personal conflict, so the next stream will be next Tuesday. And like I said, I'll post that on Twitter. But besides that, thanks for sticking around, everyone, and I hope you all have a great night.